Hello, Assalamualaikum and a very good morning to all my panels. Today I would like to present my bachelor degree project 2 about the topic of nickel chromium electrodeposition in deep eutectic solvent on steel substrate surface properties and its deposition mechanism. My name is Mohamad Al-Haziq bin Mohamad Saharuddin with my metric number B0518-10033. I'm being supervised by Dr. Mohamad Zaimi bin Zainal Abidin. Okay, for the introduction, nickel chromium alloy is a combination between the nickel elements and also chromium elements, which produce a material of high corrosion and oxidation resistant. Okay, this material is widely used in some industries just like aerospace, militaries, and also oil and gas due to its unique chemical and also mechanical properties. Okay, based on the high demands, the electrodeposition method can be an alternative way to overcome the constraint of conventional method, which required a lot of time to produce. Okay, through this method, the production of a greater nickel chromium alloy coating will use a DES solution, stands for deep eutectic solvent, that determines a stronger interaction between involving elements. Okay, for the problem statement part, in previous practice, nickel chromium alloy it has been produced by applying the conventional process, which is the powder metallurgy method, which requires a lot of time to complete. In order to solve the problems, the electrodeposition process have been designed to replace the previous practice. The deposition mechanism has been studied in the previous thesis, considering using the cyclic voltammetry measurements that require an investigation on the effect of current density, liquid bath composition, and also the effective temperature for applying on the nickel chromium alloy coatings. The ratio for the deep eutectic solvent solution and also the arrangement of material element of the electrode must be determined to avoid any confusion resulting from the investigation. Okay, for the objective, there are two objectives that have been highlighted for this project, which is to investigate the relationship between the effect of current density on the nickel chromium alloy coating analysis, and also to investigate the relationship between the temperature and also the effect of thickness on the nickel chromium alloy coating analysis. Okay, for the literature review, this is the part where I searching for my finding on the previous research and journals. Okay, this is some of the authors that have mentioned about what is the electrodeposition about, and what solvent type of solvent that they use to uh, making the electrodeposition. Okay, for the methodology part, the left side we can see the deep EUTECTIC solvent table. It shows the two solvent that I used to, which is the ethylene glycol with ratio of 2 and the kaolin chloride with ratio of 1, by mixing up at 80 degrees Celsius for 30 to 60 minutes. Okay, then the below side we can see the diagram of position of my electrode for anode and cathode. For anode, we place the graphite or ITO, and for the cathode, we place the steel substrate. Okay, for the right side of the screen, we can see there is a flowchart of my fully process of my project, starting with the substrate preparation, then electrolyte preparation, goes to the electrode deposition process, and then finally go to the XRD and SEM analysis to set up the result for my sample that have been done, and then go to the result and discussion. Finally, I'm done. Okay, for the experimental setup, the figure above shows the experimental setup during the electrode deposition process. Okay, for the left side, we can see my apparatus placement, which is I use the red alcohol thermometer, hot plate stirrer, the aluminium retort stand, and also the DC power supply. Okay, for the for the right side of my screen, we can see there are some small apparatus such as the graphite or ITO for the my electrode, the beaker of 100 ml quantity, the PTFE magnetic stirrer, the steel substrate, which is my sample for the cathode, and also the 3 retort clamp. Okay, for this section, we can see the table above shows about the perimeter of the bath composition and also the substrate sample. Okay, for the upper side table, it shows the bath composition that I used to, which is the nickel chloride hexahydrate and also the chromium chloride. By mixing at 40 degrees Celsius for 15 minutes, and then the left side and the right side, there is a picture of my steel substrate, which the sizing I use is 20 mm times 20 mm, which is the my steel plate. Okay, for the below side of the table, we can see the parameter I used to, the temperature 60, 70 and 80 degrees Celsius, and for the current density I use is 1 milliampere, 10 milliampere and 50 milliampere with addition of 100 milliampere. Okay, for the SEM analysis, what we can see from the screen, I only choose the best 3 sample from what I have done in the electrode deposition process, which with the current density of 100 milliampere. Okay, for the temperature I use is the 60, 70 and also the 80 degrees Celsius from the current density of 100 milliampere. And then I choose the magnification of 500 and also the 1000 to see the surface morphology of my plating. Then what we can see on the 60 degrees Celsius, there is a lot of scratch on the surface, and then when the temperature rise up to 70, the scratches is reduced and the surface is more
more smooth. And then when the 80 degrees Celsius is quite with the 500 magnification, there is no scratches at all. Okay, for the SRD analysis, just same like the SEM analysis, I use the 3 best sample, which is the 100 milliampere. Okay, for the temperature, I choose the 60, 70 and also 80 degrees Celsius. And the graph choose is a graphic and pattern graph. Okay, what we can see from the 60 and up to 70 and finally to 80 degrees Celsius, there is a difference between the graph. Okay, for the x-axis is the position, and for the y-axis is for the peak of the material position. Okay, what we can see from 60 until the 80 degrees Celsius, the position of material is become increased, and also the peak of the material position is also become increased. Okay, for my addition analysis, I use the OM analysis. Okay, on the right side, we can see the example of my OM figure. Okay, the table describe about the thickness of each sample after the experiment has been done. Okay, what we can observe, there is a might fluent and different from the sample to sample about the thickness, or maybe this is gone because the sample I have grinding it manually, maybe. Okay, for the last part is a conclusion. I might summarize that the different parameter decide on the solvent temperature and also the current density effect on the different electrodeposition coating results. And then the higher nickel chloride and chromium chloride concentration, plating bath may producing higher nickel chromium alloy thickness. Okay, the last is the higher the temperature and the current density used on the electrodeposition may effect on the lower the number of scratches found on the surface morphology. Thank you and goodbye.